Superheat in heating and air conditioning with a split unit, and meaning one may have a condenser outside and an air handler inside with two copper lines going through the wall, etc. And at this point, one needs to figure out what the superheat is. There's superheat and subcooling. Superheat is done from the low pressure side. Subcooling is done from the high pressure side. Meaning low pressure, if one looks at the numbers here, like the PSI, the PSIG here, and then come over here and it's 100, 200, the numbers get higher faster here than they do here. So it's a superheated vapor. So at this particular point, one needs to figure out what the saturation temperature is. So with these old analog gauges, it's kind of like it may be like a quasi. Now the HVAC guys can kind of leave some information in the comments, but the gauges may act sort of like a pressure temperature chart. And one may ask, well, what is a pressure temperature chart? It's this little thingummy here that one can pick up from the heating and air conditioning unit, and it's like tells you what type of refrigerant here, what type of degrees here. So notwithstanding, to find the saturation temperature, we need to, in order to find the superheat, we need to first find the saturation temperature. So if we take and go here and say, if we take the temperature here and we're using R22, the green, I think it's green looking color here, maybe R22, the pink may be 410A, and the orange may be, I'm not sure if that's 404 or something, that may be used more in refrigeration. But say hypothetically the R22, if we go to 50 degrees here and cross-reference it to the temperature, this may be the saturation temperature, so it would be a smidgen under 30 degrees. So now, if we add more pressure to the system, if we have more pressure, the temperature may increase. So if we go up to, say, close to 75 degrees, we're a smidgen over 40, or right around 40 degrees. So, and now if we go to 100 PSIG, when we go to 100 PSIG, and I hope I didn't say temperatures on this, PSIGs on this. I hope I didn't misspeak here. And if I did, I'm correcting myself. But say, hypothetically, if we go at 100 PSIG and cross-reference this, we're at 59 to 60 degrees. So this may be saturation point. Now, what is saturation point? Saturation point is when liquid and vapor may coexist, and at this point, then it begins to go from liquid to a vapor. So at the point where it goes from a liquid to a vapor, then we say this would be the saturation temperature when they coexist, and this would be 100. Say come over here and it would be 59. So when we come over here, we may say, well, this might be 59 degrees. This may be 59 degrees saturation point. So at this particular point, we take and we say 100, cross-reference this here to 59 or roughly 60. Then we take our temperature probe and put on the line set. The larger line would be the suction line. And when we place this on the suction line, we get a temperature there. So then we just take this simple formula and we take the line temperature, whatever that may be, minus the gauge temperature. So hypothetically, if the gauge temperature was 59 or just say 60, we'll just round it off to an even number to make it simpler. And if the line temperature, say, was 75, so we would take 75 minus 60, and this would leave maybe 15 degrees superheat. So line minus the gauge. So and again, this would be considered the gauge side here. So if we go over to 100 and we cross-reference it here, we're at 59 or 60, but we'll just cross-reference it here. And so this would, but a good number here would be somewhere in the range of 40, 45 maybe. I'm not certain on that, the HVAC gurus, because this coil, when the refrigerant begins to boil, it absorbs heat, and once it absorbs heat, it doesn't need to be below 30 or the coil will freeze, and then it begins to get warmer, and it goes into, and that's what the superheated vapor, and this is how we calculate it. But this is the saturation temperature, so we take the saturation temperature for the superheat and simply take the line temperature. And one may ask, well, how is this done? There's a little clamp that you can put on there and get the temperature. There's some meters that read it. Now, if the HVAC guys would chime in, the little light thing that you shine on there and get the temperature, I'm not certain if they can add this, how accurate that would be. But the clamp, but if you put the clamp on there and you got this temperature minus this temperature, this would be the saturation point, this would be 60. So if the line temperature were 75, that would be 15 degrees superheat. So this is just a way to understand this, and this is saturation temperature. So the saturation temperature, so essentially these manifold gauges may have a kind of a quasi-PT or like a PT chart built into the gauges once one learns how to read the gauges. And then if you ask, well, what is a PT chart? It's simply a chart like this with the numbers here. So saturation temperature for heating and air conditioning. Thank you.